In this video tutorial, we're going through the compiling of SDK, and at the end we'll build an example. So before I start, let me tell you something about a small trick in Linux. You know, the path is too long here and it may not fit the entire screen. There's an easy way to fix that and make it shorter. So let me maximize this, and the prompt characteristics are stored at a value called PS1. As you can see, I'm echoing that out, so you see it's very cryptic. We don't really care about the entire thing. I only need to change one character, so I just copy that and basically export it back to the PS1 value by typing export and PS1 equals to, I type two quotations and I paste that value in between the quotations. So now the only thing that I need to change here is this W here. It's lowercase. I'll change it to the uppercase. Also, I have to make sure that there is one space actually before the last quotation. And once you execute that, you only see the last part of the path, which is a Raspberry. If you want to see the entire path, or you want to know where you are, you have to use the pwd command in order to show you the entire path. All right, now that we have done with that, let's go back to the main directory and take a look at the make file. Each make file has a help. So you can type make help and you will get presented with the help file for the make. So starting from top, you see all the default configuration, like the revision of the SDK, the target, we are building it for Raspberry, the client, and then the server, which is basically the Raspberry Pi, is based on Linux. Also, the chip revision default to C3, and in this case, the SPI is the default configuration and I2C is turned off. Also, scrolling down, so it gives you a lot of information about the make, and also when you go down, you will see that the target client here is set for the Raspberry. You could actually build it for PC or for Cortex M3, and also options to build it for a different revision of chip. Okay, so one of the options for make is make clean. That's in order to clean up all the objects from the previous build. And as you can see, it erases all the objects. Now, the command to make everything is make all. That usually takes a long time, but for the first time you do that, you have to wait until all the objects have been built. So now I cut in here and I come back when it's done. All right, good. It's done, and all the examples and everything is built. Usually you do the make whenever you've changed some files or you're adding some source code to your project directory. Now, in order to show that, let's try that as a reference. Let's try the ping command. So if you remember, the ping command will send a few bytes and we'll receive those same bytes back. So I'm going to the binary directory, the Raspberry, and then I'll type MAXQ1061 ping. As you can see, the 4 bytes that have been sent out, and then the same 4 bytes that have been received by the Raspberry, by the MAXQ1061. Now, I am going to change that command. So instead of 4 bytes, we're going to send 8 bytes. So, and then we'll recompile or rebuild, and you see the effect. So in order to do that, let's go to the source directory, and the source for that file has the same name. So the editor for Raspberry Pi is the leafpad. So I'm just typing leafpad and the MAXQ1061 ping.c, and the ampersand at the end allows you to do multiple tasks in Linux. So I'm opening the source code, and then scrolling down toward the bottom, you will see the place that the command has been executed. So the MAXQ ping, and then the argument is len, which stands for the length of the bytes, and you see the length has been defined here. So there are 4 bytes now. I am going to delete that and change it to 8. Once it's changed to 8, I save it, Control S. saves the file, and I go back here. Now, in order for you to maybe speed up, you want to open another terminal and have your build directory over there. But for now, since I'm using the same directory, I am going to cd ... going one back, and then again cd ... and then now on the main directory. Just make sure that I am there. So ls-l, it tells you all the files in that directory. And then in this case, now I'm going to only use the make, which is basically the same as make all. And you will see this time, since only one file has been changed, the build time is shorter, and the only file that needed to be changed is that, and the object related to that ping. As you can see, we're done. Now let's go back again to the binary directories. So toolbox, bin, and raspberry, and then we can type MAXQ1061 ping. And as you can see now, there are 8 bytes instead of 4 bytes that we had in the previous build. So it basically means that the changes to the source file has taken effect. Now, let's do that. Let's go and open the make file. So I want to point out a couple of things in the make file itself. So when you type make, there are usually options in front of make file that we can type. And the options are explained here in the, usually it's at the bottom of the, they're here. So you can see like you can target like different part of the SDK to build, so you don't have to wait long for the entire package to be built. So in this case, we are building the toolbox. Now I'm going to do that. I'm gonna use this as a make option and put it in front of the make command. Now, before we do that, let's go back and change the 8 to 4, the length of the ping file, so we would see the effects. So let's go cd ... slash ... and then we're in the main directory, and then I just copy and paste the option, and we just wait for the make command to finish. So it seems that this time is could be just a little bit faster. Okay, we're done. Now let's go to the binary directory of the raspberry. So that will be toolbox, and then the binary, and then raspberry. And let's type again the ping. Okay, so now you can see that there are 4 bytes now again. So it's back to the same original file that it was before. So in the next videos, I'm going to go through the command, the structure, and some more details of MAXQ1061.